Good morning one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today our topic is Modification by Inclusions and Confinement. In ground improvement techniques, till now in previous lectures we understand what are the various techniques which are modified by mechanical modifications based on the hydraulic modification and physical and chemical modifications. Now we have another type of ground improvement techniques by inclusions and confinements. So in this lecture we are understanding the modification by inclusions and confinements. In this lecture these are the objectives we are going to understand. Those are: understand the fundamental principles being ground improvement using inclusions, learn about the various types of inclusions and their specific effects on the soil properties, explore the concept of confinement and its impact on ground stability, examine real-world applications and examples of ground improvement using inclusions and confinement, summarize key takeaways and discuss future research directions and practical applications in geotechnical engineering. These are the objectives of this lecture. In ground improvement techniques involves inclusions and confinements are crucial in geotechnical engineering to enhance soil properties. So we have a different number of soil properties. Those are all going to enhance using these inclusions as well as the confinement, and ensure the stability and safety of the structures built on problematic soil. These techniques modify the ground by incorporating different materials, and it's not true that foreign materials means those, whenever the soil is there, those kind of, not such type of material. We are going to use other kind of different type of properties, whatever it may be, we are going to inclusive. So that's meaning of these foreign materials. Are by applying constraints, that is nothing but the confinement, thereby improving its load bearing capacity, reducing settlement and mitigating risks associated with poor soil conditions. In this ground improvement by inclusions type of inclusions: granular inclusions, geosynthetic chemical inclusions. In these granular inclusions, in these granular materials such as gravel, sand and crushed stone are used to improve soil compaction and drainage. So in this granular inclusion we are going to apply, these materials are often used in construction of roadbeds, foundation bases and embankments. Benefit: enhanced load distribution, increased permeability and improved compaction characteristics. In granular inclusions, these are the things we are going to understand as a type of inclusion improvement of the ground. In geosynthetics description, geosynthetics include geotextiles, geogrids, geomembranes and geocells, which are synthetic materials used for soil reinforcement. For soil reinforcement, we are choose this geosynthesis modification by inclusion for getting the better soil conditions or desired soil properties. We are applied these kind of geosynthetic types in widely used in road construction, retaining walls, erosion control and landfill liners. In these, using this kind of geosynthetics by modification, by inclusion modification, it increases its soil strength, reduces deformation and enhances drainage and filtration conditions. Chemical inclusions. In these chemical stabilizers such as lime, cement, fly ash and other additives are mixed with soil to improve its properties. Such type of soil modifications are based on the inclusions, that is nothing but chemical inclusion. We are going to apply these kind of soil chemical inclusions in soil stabilization for roads upgrades, foundation, and also in abutment conditions. Using these kind of chemical inclusions, we may get the increased soil strength and stiffness, reduced plasticity and swelling potential, and improved durability. We may get these kind of benefits for soil properties using these kind of chemical inclusions. In what are the effects of inclusions based on the mechanical properties, hydraulic properties, and chemical properties? In mechanical properties, once we are including the desired, what are the required type we are going to include based on the mechanical properties such as geogrids and chemical stabilizers can significantly increase the soil's bearing capacity. In stiffness point of view, geosynthesis and granular inclusions enhance the soil stiffness, reducing the settlements and deformation. In load bearing capacity, the overall load bearing capacity of the soil is improved, allowing for safe and more stable constructions. In hydraulic properties, inclusion of these modifications by inclusions, in these granular inclusions and certain geosynthetics improve the soil's drainage properties, reducing the risk of waterlogging and increasing stability. In hydraulic properties, we are considering this permeability. The permeability of the soil can be controlled to suit specific engineering requirements, such as in the case of landfill liners. As per chemical properties of the soil, because of these modifications by inclusions, stabilization, chemical inclusions react with soil particles, leading to the formation of cementitious compounds that increase soil strength and reduce compressibility. In resistance, improve resistance to environmental factors such as freezing and thawing cycles, erosion, and chemical attack. In mechanism of modifications, we have to understand various parameters. Those are reinforcement, stabilization, drainage improvement. In reinforcement, adding inclusions such as geogrids and geotextiles reinforces to soil structure, providing additional support to resist deformation. It impacts enhanced stability and load distribution, reduced risk of soil failure. In the mechanism, that stabilization, the chemical reactions between inclusions, example lime, cement, and soil particles, lead to the formation of stable compounds. Impact of these mechanism of modification: increased soil strength and stiffness, reduced plasticity, and minimized shrinkable behavior. In drainage improvement, incorporating granular materials and drainage geosynthesis improves water fall through the soil, reducing pore water pressure. As an impact of this mechanism of modification, it reduces the soil, lower the soil liquefaction risk, and enhance the stability during wet conditions. Ground improvement by confinement. In confinement, in this concept, that confinement involves the application of physical constraints to soil, enhance its stability and load bearing capacity. Restricting soil movement and deformation, confinement techniques can significantly improve the performance of ground materials. In this, different types of confinements are there. The one is encasement. In this, soil is encased using materials such as geotextiles or geomembranes, often applied to soil columns or embankments. In this type of confinement, we are going to use in the construction of reinforced soil slopes, embankments and foundation pads. Using this type of confinement, it leads to increased stability, reduced lateral movement and enhanced the load bearing capacity. And the other type is containment structure. In this structure, such as retaining walls, coffer dams and gabions are constructed to confine soil within a designated area. Such type of confinement structure applied in soil stabilization, waterfront constructions and excavation support. According to this type of modification by inclusions in confinement, it is improves using this type of confinement structure. We improve the soil stability, control deformation and protection against erosion. And another method is there, that is soil nailing. In soil nailing, steel bars or anchors are driven into the soil to provide reinforcement and stabilize slopes or excavations. This type of soil nailing technique is used in soil stabilization, retaining wall reinforcement and excavation support. Once we are applying this type of soil nailing, we are getting the benefits or what outcomes are increased soil stability, reduced risk of soil failure and enhanced the safety during construction. These are the types which are in this confinement: encasement, containment structure and soil nailing. What are the effects of this confinement? Increased stability, enhance the load bearing capacity and controlled deformation. In increased stability, confinement reduces the soil movement and deformation, leading to improved stability of slopes, embankments and foundation soils. It results the lower risk of landslides, soil erosion and structural failure. Enhanced load bearing capacity. Effects of this confinement, those are: confinement allows soils to support higher loads without excessive settlement, making it suitable for heavy structures. Results: safer and more reliable foundation performance are for buildings, bridges and other infrastructure. In effects of confinements, control deformation affects the confinement techniques, limit of soil deformation, maintain the integrity of structures and preventing excessive movement. It reduces maintenance cost and extended lifespan of structure. In confinement applications, industrial applications, environmental applications are there. In industrial application, constructions, mining, oil and gas. Using this modification of confinement in construction industry, ground improvement for foundation of buildings, bridges, highways and other infrastructure projects. Once we apply this confinement, that outcomes gives the enhanced stability, reduced settlement and improved load bearing capacity. And also it ensuring safer and more durable structures. In mining, this confinement, stabilization of tailing dams, mine slopes and other mining related structures. Once we apply this confinement, the results are increased safety, reduced risk of slope failures and improved environmental protection. In oil and gas, ground stabilization for pipelines, drilling platforms and other infrastructure. Once we are using this confinement, after that we are getting the enhanced stability in challenging environments, reducing risk of structural failure and improved operational safety. In environmental applications, landfill liners, erosion control, groundwater protection. Once we apply this modification confinement using geosynthetics and chemical stabilization to create impermeable barriers that prevent this contamination, in this we are going to benefit improved environmental protection, reduce the risk of groundwater contamination, and enhance the landfill performance. In erosion control, we are going to introduce these confinement technique that reinforcement slopes, embankments and shorelines to prevent soil erosion and protect infrastructure. We are getting the benefits of increased stability, reduced erosion risk and improved longevity of this infrastructure. In groundwater protection also, this confinement is helpful. We are going to utilize this confinement technique, modification in ground improvement, improving the drainage and reducing soil permeability to protect groundwater resources from contamination. Once we apply this confinement, we are getting the enhanced environmental protection, reduce the risk of groundwater pollution and improved sustainability. Modification by inclusions and confinement. In future trends, what kind of confinements are required for getting the better results in this particular field? In sustainable ground improvement, developing eco-friendly techniques and materials focus on those kind of it leads to improve that, minimize the environmental impact. Example, using recycled materials, biogas geosynthesis and low carbon chemical stabilizers. Smart geosynthetics. In this focusing, creating geosynthetics with abandoned sensor for real-time monitoring of soil control, soil conditions and structural performance. Example, smart geotextiles that provides data on soil moisture, strain and temperature, enabling proactive maintenance. In advanced modeling and simulation, it needs focus on utilization computational tools and advanced simulation techniques to optimize ground improvement designs. Example, finite element modeling and machine learning algorithms to predict soil behavior and improve the design accuracy. Design accuracy. These are the future trends. We need to focus on more. These means it reduces the environmental effect and reduces the time, and the production also we will get within the less time using this artificial intelligence and machine learning. Overall summary of these modification by inclusions and confinement. In this ground improvement by inclusions involves incorporating the foreign materials to enhance the soil properties, including strength, stiffness and drainage. In confinement techniques, we apply physical constraints to improve ground stability and load bearing capacity by restricting soil movement and deformation. Both methods are essential for ensuring the stability and safety of structures built on challenging soils. So these applications span across various industries including construction, mining, oil and gas environmental protection and erosion control. Future research and development will focus on sustainable ground improvement techniques, smart geosynthetics with real-time monitoring capabilities and advanced modeling and simulations for optimized designs. So this is the overall summary of the lecture. Understanding the principles and applications of ground improvements by inclusions and confinements is essential for geotechnical engineers. These techniques enable the development of effective solutions for enhancing the soil properties, assuring the stability and safety of the infrastructure, contributing to the advancement of the field and the development of the innovative sustainable engineering practice. These are some of the web references for understanding the ground improvement techniques. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.